Lecture 33. Women in Science Throughout History title slide appears with an artistic collage of women, scientists through the ages. Welcome to our exploration of one of science's most enigmatic narratives, the veiled legacy of women who shaped our understanding of the natural world. Today, we're unraveling the cryptic tapestry of women in science throughout history, excavating the buried contributions that have too often vanished into the shadows of time. Science, that most rational of human endeavors, has paradoxically harbored one of humanity's most irrational prejudices: the systematic exclusion of half our species from its formal pursuit. Yet, like water finding its path through stone, women's intellect has persistently found expression throughout the centuries, often flowing through unseen channels or carving unexpected routes around the barriers placed before them. Timeline appears showing ancient to modern periods with key female scientists highlighted. Our journey begins in antiquity, where we encounter the first whispers of women's voices in the scientific dialogue. In ancient Egypt around 2700 BCE, Merit Ta emerges from the mists of time as possibly the earliest named woman physician in history. Her image, immortalized in a tomb in the Valley of the Kings, stands as a silent testament to women's earliest documented contributions to medicine. Centuries later, in Alexandria, that luminous crossroads of ancient knowledge, we encounter the brilliant Hypatia. A mathematician, astronomer, and philosopher of extraordinary talent, Hypatia's life in the 4th century CE embodied both the possibilities and perils facing women of intellect. Her gruesome murder by a mob in 415 CE serves as a haunting metaphor for the violent suppression of women's intellectual authority throughout history. Not far away, in Hellenic Egypt, another woman carved her name into scientific history. Maria the Jewess, working around the 1st century CE, engineered sophisticated chemical apparatus including the water bath, still known today as the bain-marie in her honor. Her innovations in distillation equipment continue to echo through modern laboratory design, an invisible inheritance from an alchemist whose gender has been all but forgotten in the transformation of alchemy into chemistry. Medieval manuscript illustrations of women healers and naturalists. As Europe descended into its medieval period, women's scientific work found refuge within the walls of convents. These sacred spaces became unexpected sanctuaries for female intellectual life, where women could engage with natural philosophy under the protection of religious vocation. Among these remarkable women, Hildegard of Bingen emerges as a captivating enigma. This 12th century Benedictine abbess crafted works spanning medicine, natural history, cosmology, and philosophy. Her Physica and Causae et Curae captured detailed observations of the natural world, intertwining empirical knowledge with spiritual understanding in a way that reflected medieval approaches to nature. Her writings on the medicinal properties of plants reveal a mind keenly attuned to the subtle patterns of the natural world. In the medical school of Salerno, Italy, we encounter the mysterious figure of Trotula. Whether the name represents one woman or several female physicians remains debated, but the gynecological and obstetrical texts attributed to Trotula remained authoritative for centuries. These works' matter-of-fact approach to women's medicine contrasts sharply with later periods when women's bodies became increasingly mystified and female practitioners were pushed aside. Portrait of Margaret Cavendish and frontispiece of her book, Observations upon Experimental Philosophy. The Renaissance and scientific revolution brought new possibilities and complications for women in science. Margaret Cavendish, Duchess of Newcastle, exemplifies this paradox. Born into privilege in the 17th century, Cavendish used her position to engage boldly with the emerging experimental science of her day. Her observations upon experimental philosophy challenged the mechanical philosophy of her contemporaries, proposing instead a vitalist view of nature that was both innovative and prescient. Yet Cavendish's story also reveals the profound limitations women faced. When she became the first woman to attend a meeting of the Royal Society in 1667, it was as a curiosity rather than a colleague. She was permitted to observe but not to participate fully in scientific discourse. Her work, though published under her own name, itself a radical act, was often dismissed as the eccentric musings of a noblewoman rather than serious natural philosophy. Side-by-side images of Maria Sibylla Merian's detailed insect illustrations and Émilie du Châtelet's physics equations. The 18th century witnessed women creating unprecedented pathways into scientific inquiry. Maria Sibylla Merian, the German-born naturalist and scientific illustrator, exemplifies the power of determined observation. At age 52, she embarked on a dangerous expedition to Suriname to study insect metamorphosis in the tropical environment. Her exquisitely detailed illustrations, published in Metamorphosis Insectorum Surinamensium, revolutionized entomology by depicting insects within their ecological contexts, a holistic approach well ahead of her time. In France, Émilie du Châtelet defied convention to become one of history's most formidable mathematical minds. Her translation and commentary on Newton's Principia remains the standard French version to this day. Moreover, her experiments with energy demonstrated that the energy of a moving object is proportional to the square of its velocity, not simply to velocity as Newton had suggested. This finding anticipated the concept of kinetic energy and the conservation of energy, fundamental principles of modern physics. Meanwhile, in the night skies over England, Caroline Herschel was discovering comets and cataloging nebulae. Initially serving as an assistant to her brother William, she transcended this role to become the first woman officially recognized as a professional scientist, when King George III granted her a salary as her brother's assistant in 1787. She later received a gold medal from the Royal Astronomical Society for her catalogue of nebulae. Images of Mary Anning with fossils and Laura Bassi lecturing, the early 19th century reveals a fascinating paradox in women's scientific participation. Take Mary Anning, whose fossil discoveries along the cliffs of Lyme Regis in England profoundly shaped our understanding of prehistoric life. Her findings of complete ichthyosaur and plesiosaur skeletons helped establish the reality of extinction and the antiquity of life on Earth. Yet despite her expertise, Anning remained an outsider to formal scientific institutions, making a precarious living selling fossils while male geologists built their reputations on specimens she discovered. Across Europe, a few exceptional women managed to penetrate academic institutions. Laura Bassi, appointed professor of anatomy at the University of Bologna in 1732, conducted groundbreaking research in mechanics and hydraulics, publishing 28 papers on physics and mathematics. As one of the first women to hold a university chair in science, Bassi represents both the possibility of female academic achievement and its extreme rarity in the early modern period. Split screen showing Mary Somerville's mathematical writings and Ada Lovelace's algorithm. As the 19th century progressed, women's scientific work gained incremental recognition. Mary Somerville's success illustrates this shift. Self-taught in mathematics and astronomy, Somerville translated Laplace's Mécanique céleste, adding explanatory notes that clarified the original. Her subsequent works, including On the Connection of the Physical Sciences and Physical Geography, synthesized knowledge across disciplinary boundaries, establishing her as one of the most respected scientific minds of her era. Oxford's Somerville College stands as a testament to her influence. In this same period, Ada Lovelace was conceptualizing what would later be recognized as the first computer algorithm. Collaborating with Charles Babbage on his analytical engine, Lovelace perceived possibilities that eluded even Babbage. She envisioned that such a machine could manipulate symbols as well as numbers, potentially creating music or art. Her notes on the analytical engine, published in 1843, contained what is now considered the first algorithm designed for machine implementation, earning her recognition as the world's first computer programmer. Images of Marie Curie in her laboratory and Lise Meitner at work. The turn of the 20th century brought both profound breakthroughs and persistent barriers. Marie Skłodowska-Curie transcended seemingly insurmountable obstacles of gender, nationality, and financial hardship to pioneer the field of radioactivity. Her discovery of the elements polonium and radium, her development of techniques to isolate radioactive isotopes, and her application of radioactivity to medicine transformed science. As the first person to win Nobel Prizes in 2 different scientific fields, Curie shattered precedents while establishing new standards of scientific rigor. Yet even as Curie was celebrated, other women scientists remained in obscurity. Lise Meitner's crucial role in discovering nuclear fission exemplifies this pattern. Despite conducting the theoretical work that explained the experimental results of her longtime collaborator Otto Hahn, Meitner was excluded from the Nobel Prize awarded for this discovery. Her Jewish heritage in Nazi Germany compounded the gender discrimination she faced, forcing her into exile in Sweden, while her contributions were temporarily erased from scientific history. Triptychs showing Rosalind Franklin's X-ray diffraction image of DNA, Barbara McClintock with corn specimens, and Katherine Johnson at NASA. The mid-20th century reveals a pattern of brilliant women whose contributions were critical, yet often unacknowledged. Rosalind Franklin's X-ray diffraction images provided the essential data for understanding DNA's structure. Yet her premature death from cancer and the politics of science left her contribution unacknowledged when the Nobel Prize was awarded to Watson, Crick, and Wilkins in 1962. Barbara McClintock's groundbreaking work on genetic transposition in corn was initially met with skepticism by a scientific community unprepared for her insights about jumping genes. It would take decades before her discoveries were fully appreciated, finally resulting in a solo Nobel Prize in 1983. At NASA, Katherine Johnson's mathematical genius calculated the trajectories that sent astronauts safely into orbit and to the moon. Working as a human computer, when electronic computers were still in their infancy, Johnson overcame both gender and racial barriers in one of the most technologically advanced environments of her time. Her story remained largely untold until recent years, a poignant example of how women's contributions, especially those of women of color, have been systematically obscured in scientific narratives. Data visualization showing increasing percentages of women in various scientific fields over time. The pattern we've traced through history reveals a paradoxical truth. Women's exclusion from science has never been complete, but their inclusion has never been unconditional. At every step, exceptional women have defied limitations to make contributions that could not be denied, even as institutional structures evolved new ways to marginalize their participation. Today, women represent growing percentages of the scientific workforce in many fields, yet disparities persist in leadership positions, citation rates, and recognition. The historical pattern suggests both hope and caution. Progress has been real, but never automatic nor complete. What might we learn from this enigmatic history? Perhaps its most profound lesson lies in recognizing how much scientific potential has been squandered through exclusion. When we contemplate the achievements of women who succeeded despite overwhelming obstacles, we must also confront the haunting question of how much human talent and creativity has been lost to science through systematic barriers to participation. Inspirational image of diverse young women engaged in scientific pursuits. As we conclude our exploration of this hidden heritage, I invite you to recognize that the story of women in science is not a special interest sidebar to the real history of science. It is integral to understanding how scientific knowledge has been constructed, credited, and canonized. When we teach students about DNA without mentioning Franklin, discuss computation without acknowledging Lovelace, or explain nuclear fission without crediting Meitner, we perpetuate a distorted narrative of scientific progress. The more complete history we've explored today offers not just a corrective to past omissions, but a guide to creating a more inclusive scientific future. The next time you open a science textbook, notice whose contributions are centered and whose are marginal or missing. This awareness is the first step toward recognizing science as a fully human endeavor, one that flourishes best when drawing upon the talents and perspectives of all humanity. Thank you for joining me on this journey through one of science's most compelling untold stories.